Okay, Assalamualaikum and hi everyone. So in this video we are still in chapter 3.2 periodicity, but I will teach you a learning outcome F and G. Okay, that's mean by the end of this video you should be able to define first and second ionization energy, and then you should be able to analyze the variation in first ionization energy across a period and down a group. Okay, so kita nak tengok trend lah. Alright, so let us start with the definition of ionization energy. So before this, kita dah jumpa ionization energy, cuma kita just belajar definition, kita faham what is ionization energy. Okay, but in this chapter, kita deep sikit, kita pergi kepada first ionization energy and second ionization energy. Okay, so first ionization energy, saya simplified dia as IE1. Okay, IE stand for ionization energy. 1 here means first ionization energy lah. Okay, what is ionization energy? Minimum energy required to remove 1 mole of electron from the outermost orbital in 1 mole of neutral gaseous atom to form 1 mole of gaseous ion from its ground state. Okay, so itu definition dia. So basically, ionization energy ni adalah satu energy, okay, yang kita perlu, okay, untuk remove, untuk keluarkan 1 mole of electron. Okay, 1 mole elektron tu dari mana? Mesti dari outermost orbital. Okay, and dia akan form 1 mole of gaseous ion. Okay, so for example, let us use this example here. Okay, so this is actually sodium atom lah. Okay, and dalam sodium atom kita tahu Na ada 1s2, 2s2, 2p6, 3s1 sebab dia ada 11 proton and 11 elektron lah dalam neutral state dia. Okay, so dalam ni sini ada 1, 2 elektron, and then dekat sini ada 8, and then ini ada 1. Okay, so now we want to remove this electron. Okay, kenapa specifically this electron? Sebab dia cakap we have to remove electron from the outermost orbital. So inilah orbital yang paling luar, elektron dia dekat sini. Okay, so kita nak remove that electron. Okay, so nak remove this electron, we will need energy. Okay, so energy yang diperlukan itulah yang kita panggil ionization energy. Okay, alright, so kenapa kita nak remove ni kena perlu energy? Okay, so you have to remember, elektron dengan nukleus yang dekat tengah ni, nukleus dekat tengah ni dia positively charged sebab dia ada proton, and electron is negatively charged. So there are attractive forces between nucleus and the valence electron. So ada attraction. So in order to remove this electron, we have to overcome ni, kita kena lawan attraction dekat tengah tu. Okay, baru boleh keluarkan. So macam kamu nak tarik kawan kamu keluar, tapi kawan kamu tengah ditarik oleh orang lain. So you have to pull harder lah, baru boleh keluarkan kawan kamu tu. So basically konsep dia macam tu lah. Okay, and then since kita remove 1 mole of electron from the neutral gaseous atom, okay, the phase must be gas. That means we are going to form 1 mole of gaseous ion lah. So kita akan dapat ion yang bercharge positif. Okay, so inilah elektron yang kita keluarkan. And the delta H here is positive because kita perlukan energy. Okay, if we need energy, the enthalpy change will be positive. Alright, so next kita tengok second ionization energy. IE2 is the energy required to remove 1 mole of electron from 1 mole of singly positive ion to form 1 mole of positive 2 gaseous ion. Okay, so kenapa dekat sini kita dah tak remove daripada neutral gaseous atom? Sebab ini adalah second IE. That's mean elektron kedua yang kita nak remove. Okay, so tadi initially this is sodium atom lah. Okay, but when we remove the electron yang dekat orbital paling luar tu, the outermost orbital, we are left with 11 proton, 10 electron. So that's why the charge dah jadi Na+. Okay, so sekarang kita dah ada Na+ ni, kita nak remove lagi another 1 electron. Itulah yang kita panggil second ionization energy. That means second electron yang kita nak remove. And that second electron yang kita nak remove daripada sodium ion lah, singly positive ion. Okay, and bila kita remove electron from this Na+, dia akan jadi Na2+ lah. Okay, so dia akan jadi positive 2 gaseous ion. Okay, so imagine, let's say lah kita pilih elektron ni untuk keluarkan. Okay, so dia jadi Na2+ later on. Alright, so again to remove electron we need energy. Okay, and actually the energy here, okay, enthalpy change untuk yang second IE is higher than first IE. So kenapa higher? Sebab tadi initially we have 11 proton and 11 electron. Okay, so the attraction macam okay lah, kuat lah juga. But right now we have 11 proton, 10 electron. So banyak proton yang boleh menarik ataupun memegang elektron tu. So that means we need more energy to remove the electron since the attraction is getting stronger dekat sini lah. Okay, compared to yang dekat valence shell tadi. Okay, so itu sahaja. And then let us look at important information. The magnitude of ionization energy depend on the strength of attractive forces between nucleus and the outermost electron. Okay, so this one I already mentioned just now. Okay, if the strength of attractive forces between nucleus and outermost electron is very strong, that means you need a very high energy lah untuk remove the electron. Okay, and then the lower the ionization energy, the easier it is to remove electron from atoms and form a cation. Okay, so you can look at the value of ionization energy. If the value is low, that means easy to remove the electron lah. Itu maksud dia. Compared to ionization energy yang lagi tinggi, that means susah nak remove electron. Okay, so it means the strength of attractive forces between nucleus and outermost electron reduces. Okay, so sama macam saya cakap tadi. Okay, so now let us look at the factors affecting the magnitude of ionization energy. That means apa benda yang mempengaruhi nilai ionization energy tu. Okay, so ada 3 factors yang mempengaruhi value ionization energy, and that's size or atomic radius, and then effective nuclear charge, ZEF, and shielding effect. Okay, so kita tengok macam mana size ataupun atomic radius ni mempengaruhi ionization energy. Okay, so dia kata the larger the radius, the valence electron experience less attraction towards the nucleus. Okay, so less energy is required to remove the electron and ionization energy will decrease lah. Okay, so this one sama juga, you can imagine. Okay, so let's say you have this nucleus and then kamu ada satu atom tu, dia punya elektron dia ada 2 shell je contoh. Okay, so bila dia ada 2 shell je, so you nak remove this electron yang dekat luar ni. Okay, remove. Okay, and then let's say you have another structure. Okay, ini kiranya elemen lain lah pula. Okay, so now dia ada banyak shell. Okay, so bila dia ada banyak shell, okay, so kita compare lah, kita nak keluarkan elektron ni. So yang mana lagi ionization energy dia lebih rendah. Okay, so kita boleh nampak lah yang lebih besar ni, size yang lebih besar ni, dia punya ionization energy dia akan lebih rendah compared to yang ini. Okay, first IE dia lah. Kenapa? Sebab inilah. Okay, so bila size tu besar, okay, the radius is big, that means the distance between the nucleus and the valence electron is quite far lah. Okay, so bila distance tu jauh, less attraction toward the nucleus. That means electron ni dia attracted to the nucleus but not strong. Okay, tak kuat. Okay, so bila tak kuat, that means senang lah kita nak keluarkan dia. We don't have to put a lot of energy lah. Okay, right. Tapi kalau macam this electron, since dia closer to the nucleus, okay, so bila dia closer to the nucleus, that means the attraction is stronger. So bila attraction strong, that means we need a lot of energy lah to remove this electron here. Alright, so next one kita tengok effective nuclear charge. How effective nuclear charge affect the magnitude of ionization energy. Okay, so dia kata the higher the effective nuclear charge, the stronger the attraction between the nucleus and electrons. Okay, so kita ubah sikit lah, and valence electron. Okay, so ini betul sebab memang kita dah belajar before this. Kalau ZEF tinggi, that means attraction between nucleus and valence electron makin kuat. Okay, so bila attraction tu makin kuat, that means kita nak remove electron tu mesti nak remove electron yang dari valence electron kan. So more energy is required to remove the electron. Okay, so that means we can conclude that ionization energy will increase if the effective nuclear charge increase. Okay, so meningkat effective nuclear charge, ionization energy pun akan meningkat sebab attraction dia makin kuat. Okay, and last factors affecting the magnitude of ionization energy is shielding effect. Okay, the larger the value of N, the greater the shielding or the screening effect lah. Okay, so the outer electron are less firmly held. So ionization energy will decrease as N increase. Okay, N tu apa? N tu adalah shell lah in this case. Okay, so N itu adalah shell. So you can imagine macam drawing saya tadi tu. Okay, so let's say lah kalau dia banyak shell. Okay, so ini macam ni ada 1, 2 shell only. This one ada 1, 2, 3 shell. Okay, so yang ada 3 shell ni, that's mean larger value of N lah. Okay, so in this case saya tulis ini N equal to 2, ini N equal to 3, yang the highest N dia lah. Saya tulis yang tu je. Okay, so bila lagi banyak N, that's mean the electron are less firmly held. Okay, the outer electron tarikan dia tak kuat sangat dengan nukleus. Sebab macam tadilah, bila dia jauh, elektron tu jauh daripada nukleus, attraction dia tak rasa kuat sangat. Okay, so you can imagine it as magnet. Okay, so if you have 2 magnet, you place the magnet macam very close to each other, you can feel the attraction is strong. Okay, but then when you try to macam separate the magnet, you letak jauh-jauh, you can still feel the attraction, but dia macam tak kuat sangat. Okay, so itu keadaan dekat sini lah. When the outer electron are less firmly held, okay, by the nucleus, that means it is easier to remove this electron. So kalau easy to remove the electron, that means we don't have to put a lot of energy into it. So ionization energy decrease and N dia akan increase. So kalau elektron tu kita tak perlu energy sangat untuk remove, okay, maksudnya ionization energy dia akan berkurang. Okay, so basically we are done with factors affecting the magnitude of ionization energy. So if you think back, semua factors ni related. Okay, memang related lah. Okay, so next let us look at trend of ionization energy across a period dulu. Okay, so kita nak tengok across a period ionization energy meningkat ke menurun. Okay, so before this kita dah belajar across a period, that means the proton number increase. Yes, betul. Memang macam tu susunan predictable. And we also know that across a period atomic size decreases. Okay, so that means across a period kalau daripada Na, Mg pergi Al, size dia makin kecil. Okay, kenapa makin kecil? Sebab dia punya effective nuclear charge makin meningkat across a period. Okay, so this one relate balik lah kepada formula Z. Z equal to Z minus S, where Z equal to proton number. Okay, so kalau proton number meningkat, that means effective nuclear charge akan meningkat. Okay, and then when effective nuclear charge increase, the force of attraction between nucleus and the valence electron becomes stronger. Okay, so attraction antara nucleus dan valence electron tu makin kuat. Okay, and then bila attraction tu makin kuat, and more energy is needed to remove the electron. Okay, so we can conclude that ionization energy increases when going across a period. Okay, lagipun before this kita dah belajar kat sini. Okay, so kalau size tu getting smaller, that mean dia punya ionization energy dia akan makin meningkat. Cuma ini dia nota dia untuk larger, tapi opposite je lah. Kalau smaller, that mean IE dia akan meningkat, bukan berkurang lah. Okay, so settle. Next, ionization energy down a group. Okay, so going down a group, okay, number of shell increases ataupun principal quantum number increases. Betul lah, sebab tu kita dalam predictable kan kita ada period 1 sampai period 7 kan. So maksudnya itu shell dia lah. So kiranya ada shell 1 sampai shell 7. Okay, and then lagi ke bawah, going down the group, shell dia makin meningkat. So bila shell meningkat, that means the shielding effect increase. Okay, because this number of shell yang meningkat ni bukan sekadar shell yang meningkat, tapi shell is occupied by the elektron meningkat. So bila banyak elektron, banyaklah berlaku repulsion. Okay, so shielding effect meningkat lah. Bila shielding effect meningkat, valence electron are further away from the nucleus because the electron is pushing each other. Dia tolak satu sama lain tu. Valence electron tu makin jauh dari nucleus. So bila makin jauh daripada nukleus, kita dah boleh dapat bayangkan dah, oh, attraction antara nukleus and the valence electron become weaker lah. So bila weak, that means easier for us to remove this valence electron. Okay, so bila senang nak remove, less energy is needed to remove the first electron. Atau the first electron here means the valence electron lah, sebab the first electron remove. Okay, right, and then thus ionization energy decreases when descending a group. Okay, so that means bila kita going down group, okay, ionization energy dia akan makin berkurang sebab size makin besar, jarak antara nukleus dan valence electron makin jauh, attraction makin lemah. So senang untuk remove electron. Okay, then we want to look at ionization energy but for anomalous case. Okay, so if I mention anomalous, that means ada case berkecuali. That means that case is slightly different from normal. Okay, so let us look at this graph here. Okay, so you can see that this is kilojoule per mole. That means this is ionization energy lah. Ini ionization energy dia. And then this is the proton number. So this is period 2. That means ini adalah going across a period lah sebenarnya. Okay, going across period 2, while another one is going across period 3. Okay, so kita expect, okay, I'm expecting to see graph yang straight line macam ni lah. Okay, dia meningkat tapi straight line. Sebab apa saya expecting that? Sebab kita dah belajar tadi, ionization energy across a period akan meningkat bila moving across a period. So saya expect dia untuk straight naik meningkat macam tu. Okay, tapi tak. Okay, so as you can see, saya bulatkan dekat sini. So inilah tempat yang menyebabkan dia tak jadi straight line. Okay, so the increase of ionization energy with proton number is not uniform. Yes, that means dia tak straight macam tu. Period 2, ionization energy of beryllium is higher than boron. Ionization of nitrogen is higher than oxygen. Okay, so beryllium dengan boron, okay, kalau ikut dalam periodic table sepatutnya lithium, lepas tu beryllium, lepas tu boron, lepas tu carbon, nitrogen, oxygen, fluorine, neon. Okay, that means this is going across a period lah from left to right. So we should expect beryllium punya IE, okay, to be lower than boron lah. Okay, tapi it turns out tak, beryllium lagi tinggi. So nitrogen pun sama. Nitrogen pun sepatutnya lower IE dan oksigen lah sepatutnya. But it turns out tak. Okay, nitrogen punya IE lebih tinggi daripada oksigen. Okay, kalau dalam period 3 pula, ionization energy of magnesium is higher than aluminium. Ionization energy of phosphorus is higher than sulfur. Okay, sama juga. Magnesium sepatutnya lebih rendah daripada Al tapi dia lebih tinggi. Phosphorus sepatutnya lebih rendah daripada S tapi dia slightly higher than sulfur. Okay, so these irregularities are explained by the stability of half-filled and fully filled orbital. So kenapa jadi macam ni? Okay, ini explanation dia. Ada kaitan dengan half-filled and fully filled orbital yang kita ada belajar before this. Alright, so let us look at period 2 anomalous case. Okay, specifically kepada anomalous case sahajalah. Okay, so this is beryllium punya electronic configuration. This is boron punya electronic configuration. So beryllium 4 proton 4 electron. Boron 5 proton 5 electron. Okay, so 1s2 2s2. So 2s2 is completely filled lah. Sebab apa completely filled? Kena ingat balik. Memang 2s ada 1 orbital sahaja. So dalam ni can fit 2 elektron sahajalah. For boron 1s2 2s2 2p1 partially filled orbital. Kenapa partially filled? Because dalam 2p ada 3 orbital. Tapi dalam ni hanya ada 1 electron only. So 1 electron over here. So this is what we call partially filled lah. Before this saya dah introduce kat kamu. Kalau dia bukan half filled, kalau bukan separuh, kalau bukan penuh, that means we call it as partially filled. Okay, so completely filled orbital in 2s in beryllium is more stable than the partially filled orbital in boron. Okay, so that's why, okay, bila 2s ni lebih stable, so kita kata lebih banyak energi diperlukan untuk remove elektron daripada beryllium compared to boron. Okay, so that's why ionization energy of beryllium is higher than boron. Okay, sebab dalam chemistry, kalau sesuatu benda tu stable, that means they tend to keep dia punya keadaan dia dalam keadaan tu, dalam keadaan stable tu. Dia tak nak berubah dah. Okay, sebab kalau dia ubah, dia jadi tak stable. So dalam chemistry, kalau stable, usually benda tu akan kekal dalam keadaan stable. So kalau kita nak ganggu dia punya stability tu, that means kita kena put a lot of energy lah. Okay, so that is the case here. Okay, so kita nak remove this electron yang dah memang stable keluar, kita perlu banyak sangat energy. Compared to ini less energy is needed sebab this 2p1 electron dalam ni is unstable. So bila kita remove ni and they become something yang lebih stable, so dia lebih prefer that way lah. Right? So next kita tengok pula ionization energy of nitrogen and oxygen. Okay, so nitrogen punya ionization energy is higher than oxygen. So kita boleh deduce the reason from the electronic configuration sahaja. So let us look at nitrogen 1s2 2s2 2p3, oxygen 1s2 2s2 2p4. So 2p3 is half fill. Okay, so kenapa half fill? Sebab kalau kita draw 2p3 tadi ada 3 orbital kan. So there are 3 electron. So ngamlah separuh sebab dalam ni boleh maksimum 6. So 3 maksudnya separuh lah. Okay, while for oxygen dia jadi 2p4. So bila 2p4 dia ada extra dekat elektron dekat sini, so dia menyebabkan daripada half fill tadi dah jadi partially fill. Okay, so this partially fill 2p orbital is less stable compared to half fill. Half fill is more stable. So again, bila more stable, that means we need a lot of energy to remove electron yang stable tu lah. Okay, that's why ionization energy of nitrogen is higher than oxygen. Okay, so half fill orbital is more stable than partially fill orbital. Removing an electron from half fill p orbital makes the atom less stable, less favorable. Therefore, it require more energy. This is exactly sama macam saya cakap tadi. Therefore, IE for nitrogen is higher than oxygen. Okay, so tapi kalau kita remove electron from the oxygen, okay, 2p orbital tu jadi half fill. So dia prefer, dia lebih suka keadaan tu. So that's why dia halau-halau je elektron yang dekat luar tu. Okay, itu analogi je lah. So less energy is required to remove the electron. Okay, but kalau soalan tanya kenapa nitrogen punya ionization energy lebih tinggi daripada oksigen, you should use this one lah as your answer. Okay, the same goes for boron dengan beryllium. Okay, so next kita nak tengok anomalous case untuk period 3 pula. Okay, ionization energy of Al is lower than Mg ataupun Mg is higher than Al lah. So kenapa? Jom kita tengok electronic configuration. Magnesium stop dekat 3s2 while for aluminium stop dekat 3p1. So 3s2 is completely filled or fully filled orbital lah. Tapi 3p1 macam tadi, macam case tadi, dia ada 3 orbital tapi 1 elektron je yang fill in. So maksudnya ini dipanggil sebagai partially filled orbital. So kita dah tahu dah. Okay, removing an electron from magnesium which is yang completely filled 3s orbital makes the atom less stable lah. Kalau kita nak remove electron daripada ni, menyebabkan daripada stable jadi tak stable. So it requires more energy. So more energy is needed to remove a single 3s electron in magnesium than to remove a single electron in 3p. Okay. Alright, so untuk sulfur and phosphorus, sulfur punya IE is lower than phosphorus lah. Okay, so kali ni saya bagi electronic configuration dalam bentuk orbital diagram. Okay, so from this orbital diagram, you can see clearly lah. Okay, so this one yang 3p ni dia ada 3 elektron. So ini adalah half fill lah. Okay, so half fill. While another one, sulfur, dia ada 1, 2, 3, 4 elektron. So maksudnya dia adalah partially filled orbital. Okay, alright. So kat sini tolong betulkanlah arrow ni, make it full headed lah. Okay. Okay, and then dia kata the first electron removed from the sulfur come from 3p orbital that is occupied by 2 electron which experience mutual repulsion. This make the electron easier to remove. Okay, so the way saya explain ni slightly different from before this. Okay, sebab saya cakap dalam ni ada 2 elektron, so dia macam repulsion dia lebih tinggi lah, so senang untuk remove this electron. Itu pun betul. Kalau kamu tak nak guna this kind of explanation, you can also use the same explanation as before lah. Okay, that's mean you can say that it is easier to remove electron from the 3p orbital in sulfur because the orbital is partially filled and unstable lah compared to half filled yang stable ini. Okay. Alright, so basically saya rasa kita dah settle about ionization energy sebab kita dah discuss dia punya apa tu, definition. Okay, so trend across the period down the group, and kita juga dah discuss anomalous case for ionization energy. Thank you, bye bye.